Welcome to students in the new session. In the last lecture, we have discussed about derivatives, and we know that derivative simply represents the rate of change, actually instantaneous rate of change in a dependent variable whenever a small change is being done in the independent variable. After having the concept of derivatives, we have differentiated various kinds of functions, right? And I also told you if two functions are added or subtracted, then how we can find out its derivative. Because addition of two functions or subtraction of two functions, the derivative of such functions can be calculated by finding out their derivatives separately. So functions behaves like numbers, from the very beginning. I mentioned it many times. Means if there are two functions, then we can add up, we can multiply them, we can subtract them, we can divide them. So as far as the addition and subtraction of the functions is concerned, we already completed this portion. How, if two functions are added or subtracted, how we can find out its derivative. So the next stage is what that we will discuss in today's lecture. That is, if two functions are being multiplied, then how we can find out its derivative. So before proceeding, the approach of the derivative to find out the functions if they are multiplied, we will discuss the derivatives of three kinds of functions. Number one, algebraic. Number two, exponential. And number three is logarithmic functions. So look at these three functions. Out of these three functions, if we combine any two at any time at a product, then how many possibilities we will have? We will have total 6 possibilities. And out of these 6 possibilities, we can very simply rule out the 3 possibilities, because case 1, if algebraic function is being multiplied with algebraic function, you will get a new algebraic function, right? So if two algebraic functions are multiplied, then we will get again a new algebraic function. Same happens if exponential function is being multiplied with exponential and logarithmic function is being multiplied with logarithmic functions. The remaining 3 possibilities are what? Say A represents algebraic, E represents exponential, and L represents logarithmic functions, right? These are 3 functions. So what are the 3 possibilities? Number 1, A is multiplied with E, A is multiplied with L, and E is multiplied with L. So these are the 3 basic possibilities which you can encounter during the product of 2 functions, right? So what is the approach if 2 functions are being multiplied? Such a procedure or the method is known as the product rule if 2 functions are being multiplied, and we call it as a quotient rule if a function is being divided by any other function, right? So now after addition and subtraction, the remaining 2 compositions are what? What will happen, or how we can find out the derivative of any functions, any function if 2 functions are being multiplied, and case 2 if one function is being divided by other function. So let us take the first case, that is known as the product rule. Derivative of the product of 2 functions fx and gx. For example, fx and gx are any 2 functions, right? Then how we can find out its product? Look at this. This is equals to simply first function into derivative of the second function plus second function into derivative of the first function. Look at here, we have mentioned the differential coefficient of the product of 2 functions is simply equals to, write down the first function as it is, into the derivative of the second function, right? Plus write down the second function as it is into derivative of the first function. So this is a very simple rule whenever two functions are being multiplied, and you can find out its derivative by using this product rule. I think it is clear. If anybody is having any doubt, then just mail me our concern. Likewise, if two functions are there, see, this is a special case. Instead of two functions, anyhow, if we have three functions, they are multiplied together. Say algebraic, logarithmic, and exponential. All the three functions are multiplied together. So look at this formula very carefully. How does it work? It works like this. See, u, v, w, they are three functions, right? Write down the derivative of the first function, and the remaining two will remain as it is. Plus write down the derivative of the second function, plus the remaining two will remain as it is. Plus write down the derivative of the third function, plus remaining two will remain as it is, right? If three functions are multiplied, we can use this formula in any question. If u, v, w are three functions, then by using this formula, we can also find out its derivative, right? Case 2 is known as if a function is being divided by any other function, that is known as the quotient rule. See this rule, if fx is any function and gx is any other function, right? Then its derivative is being calculated by, in denominator, what we write is square of the denominator. Whatever you are having in your denominator, make it its square, right? What is in numerator? Look at this. In numerator, first we write down the denominator as it is into, this is what? This is the derivative of numerator, minus write down the numerator as it is, and this is what? This is the derivative of denominator, right? Clear? Any derivative, if a function is being multiplied by any other function, that we can calculate by the rule which is known as the quotient rule. And the quotient rule is what? Square of the denominator will remain as it is, right? But in numerator, what we should write? Write down your denominator as it is into derivative of numerator minus write down your numerator as it is into derivative of denominator. So by using these two rules or formulas or methods, we can find out the derivative of any function in which two functions are either multiplied together or they are in division case, right? Let us take some examples to understand how these two formulas or method works. Say the case is this, e raised to the power x into log x. So see here how we will identify. We should use the product rule in this case. See, the function is e power x and then log x base e. You know, e power x is exponential function. Exponential functions are those functions which are in raise of the power of e or power of a. So here x is in power of e. So this is your exponential function. And this is, this is your logarithmic function. So e into L, this is the case, right? Exponential function is being multiplied with logarithmic function. Now you can use the product rule. See, this is y, right? So dy over dx, this is equals to what? First function as it is, e raised to the power x as it is, into derivative of the second function, and derivative of log x is 1 upon x, plus second function as it is, that is log x base e, into derivative of first function, that is derivative of e raised to the power x, and derivative of e raised to the power x will remain e raised to the power x. And the next line is what? You can take e raised to the power x common. What is left here? 1 upon x plus this is log of x base e. So this is your required derivative. Hope the method is clear before you. Simply, you will get three possibilities. One, algebraic function is multiplied with exponential function. Two, algebraic function is multiplied with logarithmic function. And three, exponential function is being multiplied with logarithmic functions. Out of these three possibilities, you can encounter any one to use the product rule. And how this rule works, I have already explained. In a very simple way, whenever two functions are multiplied, the formula simply says write down the first function as it is into derivative of the second function plus write down the second function as it is into derivative of the first function. So we can use this product rule to find out the derivative of any function when two functions are being multiplied. In case 2, see, this is what y is equals to 5 upon 3x, right? So this is what? This is a function of the type of fx divided by gx. So we will use the quotient rule, right? Simple. This is your fx and this is your dx. Now apply the quotient rule. If y is 5 upon 1 minus 3x, see, then dy over dx, what this quotient rule says is square of the denominator. So your denominator is 1 minus 3x. Here we are having 1 minus 3x power 2, right? Now come to numerator. What we have in numerator, that is denominator into derivative of the numerator. So 1 minus 3x is your denominator into d over dx of 5. 5 is numerator, derivative of numerator, minus numerator 5 as it is into derivative of denominator, that is 1 minus 3x. Clear? Now simplify it. 1 minus 3x as it is, derivative of a 5, 5 being a constant, its derivative will be 0. 1 minus 3x into 0 minus 5 will remain as it is, and derivative of 1 minus 3x. So derivative of 1 minus 3x will be what? 1 is a constant and derivative of 1 is 0, and 3x, 3 is being multiplied with a variable x. So 3 will remain as it is and derivative of x is 1. So its derivative is minus 3. So what is left? Minus 3 and minus 5, minus 15 divided by 1 minus 3x power 2. Right? And hope you will understand the idea, the approach of these two methods or rules, which are respectively known as the product rule as well as the quotient rule, by these two examples. Let us take some more examples to understand the things very clearly. Find the differential coefficient of root 1 plus x divided by 1 minus x with respect to x, right? So here our function is like this, root of 1 plus x divided by 1 minus x, right? This is our function. So this is also the case of numerator and denominator. So naturally we will use the quotient rule. So how we will use the quotient rule? See, first this can be written as root 1 plus x divided by root 1 minus x, right? Okay, this all you have studied at your earlier classes. Square root of the numerator upon square root of the denominator. Now you can use your quotient rule. This is your numerator and this is your denominator. See, 1 minus root x square, this is your denominator, right? And what we have in numerator, denominator into derivative of numerator minus numerator into derivative of denominator. See, 1 minus x square, root 1 minus x. This is your denominator into root 1 plus x d over dx of root 1 plus x. This is your numerator minus root 1 plus x is your numerator into derivative of denominator, right? What we have in numerator, that is denominator into derivative of numerator minus numerator into derivative of denominator. Now you can find out the derivatives respectively to get the required result. See, root 1 minus x will remain as it is, and how you will find out the derivative of root 1 plus x, right? See, root 1 plus x, this can be written as 1 plus x power 1 upon 2, right? Any problem? No. Now you can use the formula of x raised to the power n. If you recall, I am recalling it again. Its derivative is nx n minus 1 into derivative of this x. And derivative of x is 1. That's why we don't write. Now look this case very carefully. Here we have what we are having. We are having 1 plus x. So apply the formula. N is 1 upon 2. So this is 1 upon 2, 1 plus x, 1 upon 2 minus 1 into derivative of 1 plus x, because here we are having 1 plus x in place of x, right? And derivative of 1 plus x is fortunately also 1. So we will not mention it. So what is left here? This is equals to 1 upon 2, 1 plus x, what is left? Minus 1 upon 2. So x, 1 plus x raised to the power minus 1 upon 2, you can transform it to denominator. We can write it as 1 upon 2, 1 plus x power 1 upon 2, and this is equals to what? 1 upon 2, 1 plus x, and then root. This is the derivative of root 1 plus x. See, we have written this here, right? Similarly, you can find out the derivative of root 1 minus x on the similar pattern, right? And then simplify it. You will get the 1 upon root 1 plus x into 1 minus x power 3 by 2 as its required derivative, right? Now take another example to understand. Actually, I cannot explain each and everything because of the time constants. We are having some limited time and we have to complete each and everything within the given stipulated time. So I cannot solve each and every step, right? Take this, if y is given like this, then show that x dy over dx is equals to y1 minus y, right? I told you in the last lecture, I don't remember the lecture, that such type of questions we will face many times. And I have also told you the way or the method such type of questions are for solving such type of questions. There are three basic methods or techniques to find out the solutions of such type of questions. Number one, you can take the left hand side and simplify it and try to obtain the right hand side. This is case 1, and this case is very commonly used, right? Case 2, you can also take the right hand side, what you want to show or what you want to prove, and substitute the values, simplify it, and try to obtain the left hand side. This means take the left hand side and try to obtain the right hand side. Case 1. Case 2, take the right hand side and try to obtain the left hand side. And in some cases, or in some very special cases, what we did, we take the left hand side, simplify it up to its at most steps, and then take the right hand side, simplify it up to its most steps. Both values in the left hand side and right hand side should be equal, because this is an equation. We have to show that the quantity at the left hand side should equals to the quantity at the right hand side. So let us take this example. Here we have given y is equals to x upon 1 plus x. Then show that the value of dy over dx, x dy over dx is y 1 minus y. So simply, y is this? This is what? This is the case of numerator divided by denominator. So we will apply the quotient rule. Apply the quotient rule here. Dy over dx is 1 plus x power 2. This is our denominator. And in numerator, what we will have? 1 plus x denominator as it is into derivative of x, that is numerator 1 minus numerator x as it is into derivative of denominator, means derivative of 1 plus x is again 1. So what you will get here, 1 plus 1 plus x minus x divided by 1 plus x power 2. This will cancel out. What is left? 1 upon 1 plus x power 2. Right. So what we are getting? We are getting dy over dx is equals to 1 upon 1 plus x power 2. Right. This is our derivative. What we want to show? We want to show that x dy over dx is equals to y 1 minus y. So we should take our left hand side, right? What is our left hand side? The left hand side, see x dy over dx, right? Substitute the values and then see what happens, right? X will remain as it is. X is as it is, and the value of dy over dx just we obtain, that is 1 plus x power 2, right? So this can be written as c x upon 1 plus x into 1 upon 1 plus x, right? Because this is 1 plus x power 2. What is this? This value is given as y. So what we are getting, x dy over dx is equals to y 1 upon 1 plus x, right? Up to here it is clear. Y into 1 upon 1 plus x, right? And what we want to prove? We want to show that x dy over dx is equals to y 1 minus y. So y we are getting. How we will find out 1 minus y? See, this can be written as y. In numerator we have 1. We can add and subtract x in numerator. See, this can be written as 1 plus x minus x divided by 1 plus x. What we did here? We are adding x and subtracting x. So this further can be written as 1 plus x upon 1 plus x. Break this in two parts. Part 1 is 1 plus x upon 1 plus x minus here x upon 1 plus x, right? No problem. This and this will cancel out. So what we will get here, y 1 minus x upon 1 plus x. Now you can check the value of x upon 1 plus x is 1 minus y. So this is what we want to prove, right? Now, after having the idea of the product rule and quotient rule, the next stage is what? Derivative of a function, that is known as the chain rule. Look at this method. Actually, what we did now, see very carefully, this is y and this is x, right? This is the variable y, this is the variable x. Y is dependent on x. So what we did, we calculate the derivative of y with respect to x and we call it as derivative of y with respect to x. Clear? This is what we did till now. We were having only two variables, x and y. Y depends on x statically. That is why any change in x, the corresponding change in y will be also noticed. Now we will change the situation. What we will do, we are actually sandwiching a new variable in between x and y and then see what happens. See, this is your y and this is your x. What is our objective? we want to find out the derivative of y with respect to x, that is dy over dx, but not directly. Rather, we will take a new variable, say u here. Y is a function of u and u is a function of x, right? Here y is a function of x. We were getting dy over dx. We have sandwiched or inserted a new variable, say u, in between x and y. So y is now a function of u. So if y is a function of u, so here we will find out dy over du. And u is now a function of x, so we will find out du over dx. Right? What we want to calculate? We want to calculate the same thing, that is dy over dx. So product of this and this will give you the required derivative, that is dy over dx is equals to dy over du into du over dx. This is called as a chain rule. Chain rule means we are making a chain. We are moving from y to u and then u to x. We can also insert more than one variables in between y and x. So this chain will be extended, right? So this rule is also very useful to find out the derivatives of the various function. And in this slide, this rule is being explained. See here, we encounter some situations when y is a function of u. See, y is a function of u and u itself is a function of x. Then y is a function of f of dx, right? So in this case, if y is a function of u and u is a function of x, then we can find out the derivative by using the formula dy over dx is always equals to dy over du into du over dx. Now, let us take some examples in which we will use this chain rule, right? Okay. Example 1, find dy over dx if y is equals to e power x square. So see, this is e power x square. Think over it for a moment. Can you find out the derivative of this function without using the chain rule? Yes, of course, because we know the derivative of e raised to the power x is e raised to the power x, right? E raised to the power x into, be careful again, derivative of x, and derivative of x is 1, that's why we don't write. Use the same technique here. If y is this, then dy over dx is what? Here we are having x square in place of x. Be careful. In this function, x square is being replaced by x simply. So its derivative is e raised to the power x square into x square is being replaced by x. So what we will write? Derivative of x square, right? And so what you will get here? E raised to the power x square into derivative of x square is 2x. So its derivative is 2x e raised to the power x square. So if y is a function e raised to the power x square, then its derivative is 2x into e raised to the power x square. The same answer you can have from the solution of this question. But we want to find out its derivative by using chain rule. See, y is equals to e raised to the power x square. Here, see, y is a function of x. We are having only two variables. We will insert a new variable, say u, in between x and y. And this can be done by taking, say, let u is equals to x square, right? Look at carefully. We have taken this term x square as u. Then what is the value of y? Y will become e power u, right? If this portion we have taken as u is equals to x square, then y will be equals to e raised to the power u. Now see these two equations. Here u is a function of x. We will find out here du over dx. y is a function of u, so we will find here dy over du. So du over dx, derivative of x square is 2x, and dy over du, derivative of e raised to power u will remain e raised to power u, right? We have calculated both the derivatives. Now apply the formula of the chain rule, that is dy over dx is equals to dy over du multiplied by du over dx. What is the value of dy over du? Dy over du is eu into du over dx is twice of x. And this is what? Twice of x, as it is e. What is u? We have taken u as x square. So this is the required derivative of the given function, right? Clearly, take this example very quickly. If y is equals to 7x upon x square plus 1, its power is 3. Then find out dy over dx. See, y is equals to 7x upon x square plus 1. And its power is, say, 3. See here, y is a function of x, right? Y is a function of x. So what we will do here, we will insert a new variable, say u, in between x and y. So assume let u is equals to 7x divided by x square plus 1. So if this whole is u, then what is the value of y? Then y is u raised to the power 3, right? Okay. Now here u is a function of x, so find du over dx, and this is y is a function of u, so find out dy over du. See this? Du over dx is this by the quotient rule. After simplifying this, dy over du is simply dy over du is 3u square, but here du over dx we can use the quotient rule to find out its derivative. I have already explained the quotient rule. You should try to apply it yourself. So you will get this value. Now apply the formula of the chain rule. Dy over dx is equals to dy over dx is equals to dy over du into du over dx. Substitute these two values and then simplify it. What else you will get? That will be considered as the required derivative. Let us take one more example very quickly. If y is equals to x plus root x square plus y square raised to the power n, then prove that dy over dx is ny divided by root x square plus y square. In the same way, actually, see, let y is equals to this. This is our original function, and we want to show that its derivative is coming out to be ny divided by root x square plus y square. This is y. See here, y is a function of x only. Here a is a constant, right? We will insert a new variable u in between x and y. We take this term only, this one as u. Take this term as u. If u is x plus root x square plus a square, then what is y? Y will be left as y is equals to u raised to the power n. Now what is left? You have to find out derivative of this. So y is equals to u raised to the power n, then dy over du will be what? N u n minus 1 by the formula of x raised to the power n, right? And what about this? U is x plus root x square plus a square. So find out its derivative. I have already explained earlier how we can find out the derivative of a square root. Derivative of x is 1, and this can be written as x square plus a square power 1 upon 2. So its derivative will be 1 upon 2 x square plus a square 1 upon 2 minus 1 into derivative of x square. A square is derivative of x square is 2x. A square is a constant, so its derivative will be 0. So this 2 and 2 will be cancelled out. What is left? 1 plus, here we are having x. Transfer this power in denominator, right? Okay. One more step. 1 plus x and x square plus a square, its power minus 1 upon 2, and this is equals to 1 plus x divided by root x square plus a square. See this. This is the derivative of this. So du over dx is there, dy over du is there. Now apply the chain rule. Dy over dx is equals to dy over du into du over dx. Substitute these values. The value of this is nu n minus 1 and the value of du over dx is this, right? Now, so dy over dx n, put the value of u we have taken this, x plus root x square plus y square plus x, its power n minus 1. And this is 1 plus x upon root x square plus a square. Multiply this with this. The root x square plus a square plus x, root x square plus a square upon x divided by this, right? See, this term and this term both are same. Root x square plus a square plus x power n minus 1, root x square plus a square plus x power 1. When two numbers are multiplied, their powers are added. So n minus 1 plus 1, the power will left out n. So what is left? Root, this is left, root x square plus a square plus x. Its power is n. And this is what? This is the value of y. So what you will get here? Ny divided by root x square plus a square, right? So this is how you can prove such questions using the various approaches of the differentiation. So students, I think I should stop it here and we will continue the remaining portion of the text in the next lecture.